Hi everyone at home, welcome to another Tenfold live show. Those of you watching, boys, girls, ladies and gents, moms and dads trying to help them, their children with homework. This is another Tenfold live show on differential calculus sponsored by Liberty. Guys, you can send in all your questions on our WhatsApp or our Facebook pages. Just have a look and we'll send a topic over there that we need to send. And we will then have a look and we can put them on the Wacom and we can then answer the questions at home. Right now we are going to go into an intro video and then we'll be back to answer all your questions from home.
Calculus is a powerful and magical mathematical tool that allows us to make predictions of future outcomes and reconstruct the past. In order to be successful at differential calculus, you will need to understand the concepts of limits, differentiation by first principles, differentiation using rules, equations of tangents to graphs, cubic functions, optimization, and rates of change. Differential calculus is 35 plus minus 3 marks in the final exam, which is about 24% of Maths Paper 1.
Okay guys, hope you enjoyed that video. It's an intro video on what differential calculus is in the syllabus and how many marks you can afford to get when you write your final exam. We've got a question now from Muhayman. Let's have a look at what he has to ask us.
Tenfold, I'm Mohammed, and if you could please help me with this question, that would be a huge help. Thank you.
Okay guys, hope you got that question. We got it down over here for you so that you can have a look at it at home. This is what the question has to ask. So it starts off saying that g of x is equal to negative 8x plus 20, and this is a tangent to f of x, which is equal to x cubed plus ax squared plus bx plus 18. Now, and that is at x is equal to 1. And they want us to calculate the values of a and b. Hey guys, so let's have a look at what this question asks us. We've got a question over here regarding a cubic function, and there's a tangent to this cubic function, and they want us to solve for two values in this equation. Now, if we have to draw, let's have a look at if we draw something down over here to give you an idea of what things look like. So we have some sort of cubic function, and they tell us that at the point x is equal to 1, we have some tangent. Okay, so that's going to be the point at x is equal to 1, and it's going to be f of 1. Okay guys, so what you have over here, you got your cubic function, you got your tangent going through, and yes, a tangent can cross other parts of a cubic function. If I have to draw another tangent, eventually someplace it'll cross another part of the arm going upwards. So now let's have a look at how to solve this question. So if we get into it, we have been given the gradient of this tangent to be equal to negative 8. So negative 8 is equal to this gradient, and they're asking us to solve for a and b. Now, when it comes to solving an equation in we want to solve for a and b. It's two variables. That means we're going to need two equations to solve for a and b. We need to try and get these equations using either the derivative or plugging in x values to make an equation that has only a and b in it. So to do that, we're going to have f of 1, and that's going to be equal to 1 cubed plus a multiplied by 1 squared plus b multiplied by 1 plus 18. Now, if we've just got to simplify my right-hand side, we're going to have f of 1 is equal to 1 plus a plus b plus 18, and that there is going to be equal to a plus b plus 19. Now, we have f of 1 over here. How are we going to get this? Well, if we have a look at f of 1, we got the tangent, and we know that at that point on the tangent, we've been given the equation on that tangent, and it's also at x equals to 1. So So if we find, or if we substitute in 1 into that equation, we can then find the value for f of 1. So if we do that, we have that my equation for my tangent is equal to g of x equal to negative 8x. Let's have a look what it was. It was plus 20. And if we substitute in 1, we're going to get negative 8 multiplied by 1 plus 20. And that's going to get me a value of, that's going to be plus 20. It'll be positive 12. Okay, so we can therefore say that f of 1 is going to be equal to positive 12. So if we substitute this in for f of 1, we get 12 is equal to a plus b plus 19. And we just want a and b, so we're going to have negative 19, that gets me negative 7, is equal to a plus b. And we got one equation already. Okay, so that's one equation at the moment, guys. We now need another equation to try and solve for my a and my b. We're going to get this equation by doing the derivative, and we're going to equate it to the gradient, because remember, the derivative gives you the equation for all the gradients of the curve at certain points. So if we find the gradient of the curve, or if we find the derivative of the curve rather, we can then equate it to the gradient. So if we find f prime of x, that's going to be equal to, have a look what my f of x was, x cubed plus ax squared. Okay, so we're going to get 3x cubed plus 2ax plus b. Now we know that this is going to give me my gradient at a certain point, and if x is equal to 1, we can then say my f prime of 1 is then going to be equal to my gradient, which was negative 8. So if we substitute this in, we get negative 8 is equal to 3 multiplied by 1 squared plus 2a multiplied by 1 plus b. Just simplifying this side over here, we're going to have then that negative 8 is equal to 3 plus 2a plus b. And if we just simplify this a little bit further, we get negative 8 minus 3 is negative 11 equal to 2a plus b. And that's going to get me my second equation. Okay guys, so just an important thing to note, when you go through all these steps, be careful that you don't make any sign errors or transposition errors when you move variables or numbers across an equal sign. And also beware of what you're substituting in for your gradient when you calculate your derivative. You want to calculate your derivative, so that means you need to put in your gradient and not the value where it equals to f of that point on your graph. So be careful of that. We now have two equations. So we've got equation 1 and equation 2. That means we can now solve for my a and b. Now we've got to be careful. We're going to be very clever about which values we're going to take. Where is equation 1? There's equation 1 over here. Okay. So guys, when it comes to having your equations, you want to be very careful, or you want to be clever about which value you're going to take and substitute in to your second equation. You don't want to try and you don't want to make hassles with distribution and fractions. So you want to try and be clever about which ones you substitute in. In this case, we have a 2a, and I don't want to distribute that 2 into brackets or anything like that. It can cause some problems. So what I'm going to do is I'm going to then solve for b, my first equation, and then substitute that into my second equation. So from my first equation, we're going to have that b is going to be equal to negative 7 minus a. And we're going to substitute this part into my second equation. So we're going to get that negative 11 is equal to 2a plus negative 7 minus a. So that's just going to get me negative 7 actually. So it's going to be negative 7 minus a, and I can now solve for a because I only have a in this equation. That's going to get me negative 11 plus 7 is going to equal to 2a minus a. That's just going to get me a. And negative 11 plus 7 is going to get me to negative 4, and that's going to get me my value for a. Okay, so straightforward now, I've got my value for A. I can just take this value, pop it into my one of my two equations, and then find the value for B. Now I've already got my first equation in B. So I now know that A is equal to -7. So I can say that B is equal to -7, and that was -4, yes. So it is minus -4, and that's going to get me -7 plus 4, and that's going to get me -3. So I can therefore say that B is equal to -3. And that's my value for A and my value for B. Okay guys, so that's that. What we could do is we can check this by putting it back into my equation, but we are running a little bit short on time. Right now we're going to go into an ad break, and then we're going to be back with Sia, and he's going to take you through with another question. So stay tuned guys.